Good day, everyone. So, we are here to talk about chemistry, and we're gonna talk about the properties of solution in the category of ways of expressing concentration and colligative properties of solution in the category of mass over mass, mass over volume, or volume over volume percentage, and in the category of osmotic pressure, and also the thermochemistry, the first law of thermodynamics. So first, the ways of expressing concentration. So we're gonna tackle about the mass over mass, mass over volume, or volume over volume percentage, in which the mass percentage is equals to the mass of solute all over the mass of solution times 100%, in where the solution is equals to solute plus solvent, and the volume percentage is equals to volume of solute over volume of solution times 100%. First example, 20 grams of NaCl or salt was dissolved in 275 grams of water. What is the mass percent of salt in solution? The given are the mass of solute in which the 20 grams salt and the mass of solvent in which the 275 water. So in order to solve this, the mass percentage is equals to mass of solute all over the mass of solution times 100% is equals to 20 grams all over 20 grams plus 275 grams times 100% is equals to 20 grams all over 295 grams times 100% is equals to 6.78%, and that is the mass percent of salt in solution. So number 2 question, 20 ml of methanol is mixed with 165 of ethanol. What is the mass percent of methanol in solution, and what is the volume percent of methanol? So since the milliliter is more indicated in the given, so we're gonna find first the volume, in which the volume percent is equals to volume of solute over the volume of solution times 100% is equals to 20 ml over 20 ml plus 165 ml times 100% is equals to 20 ml over 185 ml times 100% is equals to 10.8%. That is the volume percent of methanol. So next up is we're gonna find the mass. So since density is given in the question, so we're gonna use the density formula, in which the density is equals to mass over volume. So we're gonna times it by volume so we can find the mass of the methanol. So cross out the volume, then mass is equals to density times volume. Remember that 1 cubic meter is equals to 1 milliliter. So first, we're gonna find the mass of methanol. The mass of methanol is 20 ml times 0.682 grams all over 1 ml. So cross out the milliliters is equals to 13.6 grams CH3OH or methanol. Then we're gonna find the mass of ethanol, in which the mass of ethanol is 165 ml times 0.789 grams all over 1 ml, and it is equals to 130.2 grams CH3CH2O2 or ethanol. So since we have the mass of methanol and the mass of ethanol, so we can find the mass percent now, in which the mass percent is equals mass of solute over the mass of solution times 100% is equals to 30.6 grams all over 13.6 plus 130.2 grams times 100% is equals to 13.6 grams over 143.8 grams times 100%, and it is equals to 9.46%, and that is the mass percent of methanol in the solution. So next is the qualitative properties of solution. We're gonna tackle about the osmotic pressure. Osmotic pressure formula is pi is equals to mRTI, in which the M stands for molarity, in which the molarity stands for the mole of solute all over the liter of solution, and R is the ideal gas constant, in which it is equals to 0.0826 liter times atm per mole times Kelvin, and temperature in Kelvin, T is equals to C plus 273 as the formula for Kelvin, and I in which the Van T Hoff index, and it indicates the number of ions. So the example given is that calculate the osmotic pressure of 450 ml solution made by dissolving 75 grams of salt at 38 Celsius. So pi is equals to MRTI. First, we're gonna find the molarity of the solute, in where molarity is equals to moles of solute all over the liters of solution, in where 75 grams of salt times 1 mole of NaCl all over 58 grams of NaCl. The 58 grams comes from the molar mass of NaCl, in where 23 grams of sodium, 35 grams of chlorine is equals to 58 grams salt. So since the given volume is in milliliters, so we're gonna convert it into liters. So in where 450 ml all over 1 times 1 liter per 1000 milliliter is equals to 0.45 liters. So we're gonna times it to 1 over 0.45 liters of solution. So we're gonna cross out all the same units, and it is equals to 1.3 mole NaCl all over 0.45 liters, and it is equals to 2.9 mole per liter. So since we have the molarity, so let's have the osmotic pressure of the solution. So it is equals to 2.9 mole per liter times 0.0826 liter per times 0.0826 liter times atm per mole times Kelvin. So the temperature is in Celsius, so we're gonna find the Kelvin of it, in where 38 plus 273 is equals to 311 Kelvin. So times in 311 Kelvin over 1 times the number of ions, in where the number of ions is 1 sodium cation and 1 chlorine anion, times 2. So cross out the units, and it is equals to 149 atm. So that is the osmotic pressure of the solution. So we're gonna talk about the thermochemistry, in which we're gonna discuss about the first law of thermodynamics, in where the solution is the change in internal energy is equals to heat energy plus work, in where U stands for internal energy, Q stands for heat energy. The formula of heat energy is MCAT, in where the mass times the specific heat capacity times the change in temperature. Remember that if Q is positive, then the system absorbs the heat, and if the Q is negative, then the system releases the heat, and it is called exothermic. And now the W, in which the work of the internal energy, where work is equals to negative pressure times the change in volume. Remember that if the work is done on the system, then the work is positive, and if the work is done by the system, then the work is negative. A gas absorbs 1,800 joules of heat energy and expands from 4 liters to 10 liters at a constant pressure of 4.8 atm. How much work is done by the system, and what is the change in the internal energy of the system? So since in the question it is indicated that the heat energy was absorbed by the system, then the heat energy is positive. So it's positive 1,800 joules. So now we're gonna find the work, where work is equals to negative pressure times the change of volume, where the change in volume is the final volume minus the initial volume, where 10 liters minus 4 liters is equals to 6 liters. That is the volume of the work. So we're gonna calculate now the work, where negative 4.8 atm times 6 liters, and it is equals to negative 28.8 liter times atm. So since we need joules, so we're gonna convert it to joules. So since 1 liter times atm is equals to 101.3 joules, so we're gonna times it in 101.3 joules. So we're gonna cross out the units, and it is equals to negative 2,917.4 joules. And now we're gonna find the internal energy of the system, where Q plus W, and it is equals to 1,800 joules minus 2,917.4 joules, and it is equals to negative 1,117.4 joules. So next is how much heat is absorbed by 65 grams of water if the temperature rises from 20 Celsius to 50 Celsius. The specific heat capacity of water is 4.184 joules per grams Celsius. Where the mass is 65 grams of water, the specific heat capacity of water in which the 4.184 joules per grams Celsius times the change in temperature, where final temperature minus the initial temperature. So we're gonna cross out the same units, and it is equals to 8,158.8 joules. So that is the heat energy of the solution. So if you love the discussion, please hit that like button and subscribe to our channel for more videos. Thank you for watching.